Hey, welcome to another week of STEM at Home. As you can see, the pea plants that I've been growing are no more. They only really make peas for a couple weeks, so we got lots of peas out of them, and then they stopped making peas, so we pulled those all out, we composted those, and now we're planting some new things in here. We got some radishes going on, a few other things. This week, though, we are going to be talking to you about archaeology, and we have some experts to explain to you what archaeology is and what they do as archaeologists. Well, I'm not an archaeologist, but my garden brings us to our first archaeology topic. Gardens, farming, agriculture, these are all human inventions. Right now, scientists believe that people of the past started farming around 10,000 years ago in the Middle East. Around the world, though, people invented agriculture independently from one another 10 different times. The eastern United States, including the region that now is Missouri and Illinois, is one of those 10 places where people invented agriculture thousands of years ago. The first known squash seeds that appear to be from a farm squash were found in Missouri. And we have some squashes actually over here that are a legacy of those. In Illinois, some of the earliest farm grains, chenopodium, are recovered from Illinois. And like my garden, Native Americans who lived in this region thousands of years ago would have kept small gardens to grow squash, sunflowers, which I actually have in my front yard, and other plants that they domesticated. This lets them have just a ready source of food, like we do here, to make their meals out of. So how do we know all this? Well, archaeologists working in this region have excavated archaeological sites, recovering ancient plant remains, and they studied those remains. Archaeologists are scientists who study people who lived in the past, and today you're going to hear more about archaeology from several professional archaeologists who will tell you exactly what they study and why.
Hello and welcome to Archaeology Week. I'm Dr. Corey Ragsdale. I'm a bioarchaeologist here at Southern Illinois University, Edwardsville. And bioarchaeologists are archaeologists that get the majority of their information from human remains and from the burial context. So we primarily study human skeletal or human teeth tissues to give us information about people's lives in the past. And one of the things that a lot of people don't know that's really at the core of bioarchaeology is that so much of our lifetime is stored within our bones and within our teeth. So our lifetime of health, the different things that we eat, the foods that we eat, where they're grown, where they come from, all that information is sort of stored in a permanent record that is inside of us, in our bones and our teeth. We also have records of our occupations, our behaviors, various types of things that we experience throughout our lifetimes, injuries, things like that are recorded within our tissues. So as a bioarchaeologist, we look at these things, these tissues, markers, chemicals, fractures in bones, and things like this to get information about what people were doing in the past. And so we can take this information and we can start to learn things about the differences between perhaps male and female labor, the differences between perhaps male and female diet, or the differences in diet and access to food and violence through different classes. So this is all sort of the main sort of information that bioarchaeologists are interested in. So it's a lot of the same archaeology methods and really theory that we see from other archaeologists, but again, the primary source of information for us are human bodies that are left behind. So if you have any questions about this, please contact any of us at the university. We're very good about, and through your State Historic Preservation Office, of course, they also have information about this. And thank you for joining us.
Hi, I'm Carla Hadden. I'm an archaeologist and I work at the Carbon Dating Lab at the University of Georgia. When archaeologists work in the field, they might find an old fire pit or an old garbage heap with some bones or shells or seeds. And they often want to know, well, how old is this stuff? And that's where our group comes in. We're able to estimate how old that stuff is by measuring something called radiocarbon or C14. The basic premise of this is that everything starts off with about the same amount of radiocarbon, But after you die, or after that material dies, the amount of radiocarbon declines over time. So if something has very little radiocarbon left in it, we know that it's very old. If it has a lot of radiocarbon, we know that it's not so old. But before we can do that, we have to use chemistry to clean and purify our samples. So today I'm working on some bones. These are from archaeological site in the state of Wyoming. The basic way that this works is we start off with a big chunk of bone that an archaeologist found in the ground. We take and clean a small piece of it, and we break it into really small pieces like this. Then we soak the sample in hydrochloric acid, and the reason we do that is we want to get rid of the mineral part of the bone. We just want that squishy, soft protein part of the bone. So that's what we're doing here. If you look closely, you might be able to see it bubbling. The next step is we'll clean the bone, get all that acid off of it, and then we will dissolve that sample in a less concentrated acid, and that's what's happening here. But there's still going to be little chunks of stuff, old dirt and things that are left over on the bone. So when it's done completely dissolving, we'll then filter it to get rid of all that other junk that we don't want. And so we end up with this see-through solution like this. And then the next step is we will dry that down. We'll actually dry it in a freeze dryer, and we end up with this really nice fluffy collagen. This is what we're going for. So we start with this whole bone, and we end up with this nice fluffy soft protein. This is called collagen. And then the next step in the process is we'd actually take some of this collagen and we would burn it to get the CO2, get the carbon from the material, and that's what we would use to measure the radiocarbon content. So if there's a lot of radiocarbon, it means it's pretty young. If there's not very much radiocarbon, it means it's pretty old. And that's how radiocarbon dating works.
Hi, my name is Brandon Richardson. I'm an archaeologist and assistant professor of anthropology at the University of Illinois at Urbana-Champaign. And I want to talk to you today about one of the tools that I use most frequently when I am conducting archaeological research, and that is geographic information systems. These programs are sets of software that really let you understand the spatial aspect of data. Right? This is really valuable in archaeology because we're fond of saying as archaeologists that context is the most important thing. What artifacts do you find, and what associations do these have with other artifacts? And this can go on at a lot of scales, this type of analysis, right? We can look at entire regions or landscapes. So I wanted to show off a little of what I've been doing lately using GIS. Here we are. You may not be able to tell, but we're looking at the state of Georgia right here. At last count, there's nearly 60,000 archaeological sites in the state of Georgia. Every single one of these dots is an archaeological site that's been discovered and recorded through archaeological survey or research in the state of Georgia. If you're an archaeologist and you've got a question, this is a lot of data to work with. So frequently, what archaeologists will do will be narrow their focus a little bit. And so I've done that by focusing in on one area, the area that I research most frequently, and that is the coast of Georgia. Down here you can see a much smaller set of sites. I've selected a set of sites that date to the Middle Woodland period, right? So the Woodland period, in general, spans from 1000 BC to about 1000 AD, and the Middle Woodland, as you might expect, lands right in the middle. So what I've been looking at lately are changes in how people were using the landscape between the Middle and Late Woodland periods. These sites are Late Woodland sites, in the red dots. These are somewhat later, probably about 500 to 1000 AD, give or take. These are rough estimates. And so, when you're just looking at dots on the map, this may not mean a lot. It doesn't look like there's any meaningful patterning here. So there's a lot of things that GIS lets you do. Things like running statistics or interpolating for missing data that you may not have based on what sample you have here. And so using these tools, I've been able to create these images. This is a heat map. This shows where there are concentrations of archaeological sites. This one specifically is to the Middle Woodland period, and this one is the Late Woodland period. You can tell that these two images don't quite look the same. To me, as an archaeologist, and this is room for future investigation of course, that Late Woodland sites appear to be more clustered. There are more of them closer together, and that's what you see in these dark blue splotches relative to the lighter blue that's all around. Going back in time again and looking at the Middle Woodland, you can see that these are not as dense, these darkest blue spots, and they're more evenly distributed. So maybe settlement, where people were living in the past, is a little less clustered. Now that's for the whole region. You can see here the series of islands up and down the Georgia coast. We're talking about a span of nearly 200 kilometers. Archaeology, of course, doesn't just tackle what's going on in the big picture. We always want to look at smaller spatial scales, right, to understand what people were doing, their daily lives, and that sort of thing. So to that end, part of my research in the past has been looking at one particular site on the Georgia coast, and this has been Kennan Field, which you can see here. This is zoomed in on Sapelo Island. And what I was doing there was digging one hole every 20 meters. And I was digging these holes so I could get a better understanding of what people were doing on this landscape, right? Where were their houses, right? Or where were people never using this part of the site? Here, every one of these red dots represents a singular hole I dug in the ground, or I should say that I was privileged enough to lead teams of students and volunteers to help me dig these holes. And now I can do something similar that I did for the regional scale, right? What kind of density patterns are evident? And again, if I'm looking at middle woodland and late woodland settlement, I am looking explicitly at ceramics, broken pieces of pottery. And these pieces of pottery tell us something about when sites were occupied, because we know that how people made their pots and jars and bowls, these technologies changed over time. So when we as archaeologists find different types of broken pottery, we can usually fit these into spans of time. So I did this for, again, middle and late woodland ceramics. You can see that at the site level, slightly different color scale here, light green to white, right, in the most intense, very evenly distributed, much like at the regional scale, right? Not a lot of clustering. You see little bits of ceramics all over the entire site. Whereas in the late woodland, you actually see a little less ceramic overall, but you also see that these ceramics are a little bit more clustered. And now all of these things that I've been showing you, right, this is just one aspect of what I could do with GIS. There's innumerable types of statistics, and this sort of software is used not just by archaeologists, but with any researchers and any scientists, where they have data that has an important spatial component. This has been my whirlwind tour of a little bit of archaeological GIS. I hope you enjoyed this whirlwind tour. Thanks.
Hi, my name is Carl Drexler. I work for the Arkansas Archaeological Survey, and my job asked me to investigate at least 10,000 years of human history in this area. And so I do work on everything from Native American sites going back, literally thousands of years, to some very recent sites. I've done some work on some World War I and World War II sites here in Arkansas. Right now, my emphasis really is on a couple things. I've done some work on some Native Americans, specifically a group called the Caddo people. Some of their mound sites that are here in Southwest Arkansas. And also, and this is a lot of what my better known work is on, is looking at an area called conflict archaeology, and this is any sort of site that's associated with warfare. And so a lot of it's battlefields, but there's also forts, camps, prisons, some mass graves, and also civilian sites that have been impacted by war and conflict. And so I've been doing a lot of work with battlefields, going around, working on these really expansive and large sites where you have, hundreds of acres that you have to study. We do that with metal detectors, and every artifact we find, we record the exact location of, so we can actually figure out where people were on the battlefield and how they moved around it. And we can actually identify individual regiments and units from the stuff they left behind. But as a result of me, sort of being a specialist in this area, I get calls fairly frequently about things like, I found a bullet, help me identify it. Occasionally, I get calls because someone found an unexploded cannonball and they want to know how to deal with that safely. And so I provide them, usually it's, providing a bomb squad and a little bit of a expertise on how to handle that safely so no one gets hurt. There's a lot of diversity in archaeology as far as what you can wind up working on. for my part, I love digging. I've always, found it fascinating to see something come out of the ground that hasn't been touched for, 50, 100, 4,000 years. It's always exciting. And I also do a lot of work with mapping equipment. So I use a lot of surveying tools and really fancy GPS units. There's a lot of, like I said, there's a lot of cool things you can do in archaeology. And thanks for having me.
Hi, I'm Dr. Susan Koyman, and I'm an assistant professor of anthropology at Southern Illinois University, Edwardsville. Now, part of my job, obviously, is to teach college students about archaeology, but the other part is research. And my research focuses on the archaeology of the Upper Great Lakes, particularly the region around Lake Superior and the Upper Peninsula of Michigan. And I study groups who lived in that region between 1,000 and 2,000 years ago. These are indigenous Native American people, and I focus on their pottery, diet, and cooking. I love food, so that has sort of translated into the type of research that I do. Now, one thing that a lot of people don't really realize about archaeology is that it's not just the field work. The field work is, it's the fun stuff. You think about archaeologists out there digging in the dirt, finding cool things. But for all of this, the time that we spend in the field, for every week that we excavate, there are weeks or maybe even months of time that we need to spend in the lab analyzing all of the artifacts that we found. And what are we doing? We're cleaning the artifacts, we're recording them, measuring them, and analyzing them. And that takes a lot of time. So think pottery, for instance. When you go to the museum, you often see these beautiful whole pots on display. And those are actually pretty rare. Most of the time, when we find pottery in the ground, it looks a little bit more like this. It's in pieces. It's broken. It's been in the ground for thousands of years, so it's been broken up. But even this piece is pretty whole, pretty big for what we find in archaeology. And you can see the decoration. You can kind of tell what shape and style this was. Most of the pottery that we find actually looks like this. Take a little journey with me. Oh, yeah. So it's these little tiny pieces, these little fragments. And this is why it takes so much time in the lab. We have to try to make sense of the past using these tiny little pieces of material culture. And it's challenging, but it's a lot of fun and it's really rewarding. And that's why I love archaeology.
Well, I hope you enjoyed hearing from our experts this week. I really appreciated hearing from them and I learned a lot. I think archaeology is a great field and I encourage you to try out our activities and see what you like about it and see what you can learn. I'm going to get back to my garden, but I will see you next week for another STEM at Home.